Bismillahirrahmanirrahim. Assalamu alaikum. Okay, today we will learn about incidence matrices and book we follow, that is graph and its application in introductory approach by Wilson. And first of all, what is incidence matrix for a simple graph? Simple graph, in other words, without loop. So we have already discussed about adjacency matrices. Adjacency matrix of a graph or digraph involve adjacent of vertices, and the incidence matrix involve the incidence of vertices and edges. So formal definition is let G be a graph without loop. So in whole topic or examples, we are not using the loop of a graph. Why we are not using loop in here? We will discuss later. With n vertices, label as 1, 2, 3. So the integers in circle represent the vertices, and the simple integers are represent edges. So incidence matrix usually show as I into G, I for incidence and G will be a graph. For n cross m matrix, so there are no restriction for a square matrix. It can be square or rectangle. N cross m, where n represent vertices and m are edges. So if I vertex join with j edge, then we represent it as 1, otherwise 0. So if vertex I join with vertex j, we write it as 1, otherwise 0. So here we have example. If 1 encircled vertex join with edge 1, so we write it here 1 join with 1, so 1 vertex join with 1 edge, so 1 is here. So 1 similarly 1 join with 4, number 4 edge, so 1 join with 4, here is a 4 one. In similar way, 2 join with 5 and 6, 1 and 2. So here we have 1, 2 join with 1, 2 join with 2, 2 join with 5 and 2 join with 6. In similar way, we can complete the incidence matrix here. So we have a problem here, problem 5.9. Graph is given here and we have to change in a incidence matrix. So I am just picking the part A. So I just skip one thing here. You can see here, if I am converting a graph into a matrix, the sum of columns are always 2. First column 1 plus 1, 2, 1 plus 1, 2, 1 plus 1, 2, and up to so on. So incidence matrix of a graph, in incidence matrix of a graph, the sum of all columns will be 2. Now similarly, another example, problem 5.9 here. So another question is here, is that how we represent it to 1, 2, 3, how we label the vertices or edges. So it's up to you. You can label it in any way. You can 1 place here or 2 place here, 3 either here, and 4 here, and 5 here. And in similar way, you can label whenever you want to label it. So there's no restriction to label in some certain way or in certain pattern. So one vertex 1 join with edge 1. So 1 join, we have just simply write 1 to 5 because there are 5 vertices here and 8 edges here. So 5 rows and 8 columns. So the matrix will be 5 cross 8. So 1 join with 1 and 1 join with 5. 1 join with 5 and remaining all are zeros. In similar way, 2 join with 1, 2, 6, 7, 8. So here we have 1 join with 1, 2, 6, 7, 8. In similar way, 3 join with 2 and 3. So 3 join with 2 and 3 and remaining all are 0. In similar way, you can check 4 and 5. And the part B, you can solve it in similar way. Now we have another problem. So in this problem, we have to convert a matrix into a graph. Again, I am picking the part A here. So we have to write vertices here and edges here. So 1 join with 1, 2, 3, 4. So first of all, we have to write vertices in any pattern 1, 2, 3, 4 and 5. Then 1 join with 1 edge. So 1 join with 1 edge and 1 join with 2. So 1 join with 2 and 1 join with 3 and 1 join with 4. Sorry, I am picking here the part B. So the solution is not a part of A, it's a part of B. So here we have a certain problem here. So how I am joining 1 to 2, 1 to 4 and 1 to 3 and 3 to 5. How can I draw that graph? Well, I know I am joining 1 to 3, 1 to 1, but it's a second priority. First priority is how to draw that graph, then label the vertices and edges to joining this graph. So for that purpose, just see the matrix here. So 1, 2, 3, 4, 5, the vertices are here and edges are here. So if we are taking the vertex 1, so vertex 1 and vertex 2. So 1 is joined with 2. So 1 is joined with 2 and similar way 1 is joined with 3. So 1 is joined with vertex 3. So vertically in column, we can see that the graph can be drawn by column of that matrix, and after drawing the whole graph, we can see the 1 is joined or 1 is labeled with edge 1. So we can show that 1 is joined with 1 and 1 is joined with 2. In similar way, 1 is joined with 2 and 1 is joined with 3. 1 is joined with 3. And we can place 1, 2, 3 in any way, like 1 here, 2 here and 3 here. You can join in any way. So you can complete the whole matrix to draw that graph. So next we have incidence matrix for digraph. So again, let D be a digraph, again without loop. I'm taking the graph without loop. It can be a multi edges but without loop. So in n vertices, label as, again in similar way, vertices are labeled encircled 1 to n and arc are labeled as simple integer 1 to m. And the incidence matrix of digraph will be represented by ID. Of course, I for matrix and D for digraph. So in incident matrix of digraph, we have three possibilities. First possibility is 1, second is -1, and third is 0. So we are familiar with 1 and 0. There's a new thing here is -1. So when I am placing -1, 1, I am placing 1 when one vertex 1 is joined with edge 1 in direction of 1 to 2 or 1 to 1. So if arc is outward from that vertex, I am placing it as 1. And if our arc is going toward the vertex, then I am placing -1. So you can see here an example, and if there's no arc between two vertex or two edges, so I'm just placing it as a 0. So you can see that if arc j is incidence from vertex I, then you can place 1, and if arc j is incidence to vertex I, then -1, and otherwise 0. So row 1 means vertex 1 joined with 1, vertex 1 is joined with 1. So arc is form 1, so I'm placing 1 here. And in similar way, 1 joined with 4 because arc is outward from 1, so I'm placing 1, and otherwise 0. Similarly, so for vertex 2, the edge 1 is toward 2, so -1 is there, and similarly edge 2 is again toward 2, so -1 is there. But the the arc 5 and 6 are from 2 to 6, so I'm placing 1 at the position of 5 and position of 6. And in similarly you can complete for vertex 3 and vertex 4. So here we have problem 5.11. To draw incidence matrix, I'm again picking the part A. So in part A, the vertex are 1, 2, 3, 4. So 4 are vertices and edges 1, 2, 3, 4, 5. So 5 are edges. So here 1 is joined with 1 and 1 joined with 5, but in opposite direction, so -1 at the position of 5, otherwise 0. And similarly 2 join with 1, 2, 4 and 5. So in case of 1, I'm placing -1. Why? Because 1 is toward 2, and at the position of 2 placing 1 because 2 arc 2 is from 2. And similarly 4 at position at 4 and 5, both arc are going from 2. And similarly 3 and 4, you can complete that incidence matrix for digraph. And in incident matrix of digraph, you can see that if I'm adding the vertical column, you can get 0 here. If I am adding any column, so what we get? 0. So if you want to counter check that your digraph, the incidence of digraph is correct or not, so you are just simply add the columns. If you get 0 from all the columns, so you are doing the right job. Similarly, again I am picking first part, the second part again for you. Now to draw a digraph from incidence matrix, what you have to do, we have vertex 1, 2, 3, 4 and edges 1, 2, 3, 4 and 5. So you can see here the vertex 1. So first of all, you want to draw that graph in any way. You can place 1, 2, 3, 4 it in anywhere you want to draw. So first of all, you can see the vertex 1 and vertex 2. At vertex 1 you can see 1 is here, and at vertex 2 minus 1 is there. And as I already said that the sum of all edges, all columns will be 0. So what I am seeing here is 1 at position 1, vertex 1 and vertex 2 are joined. Vertex 1 and vertex 2 are joined by 1 and minus 1. And if I have 1 here and minus 1 here, so it simply means that vertex 1 join with vertex 2 in direction 1 from 1 to minus 1. So you can see here 1 join with 2 with arc of 1 from 1 to 2. So I am labeling what we will label to that edge arc, that is 1. Here we have another example. So 1 is joined with 4, 1 with joined with 4, but in which direction? 1 joined with 4 and 1 having positive 1 and 4 having minus 1, so the direction will be 1 to 4. And what is label? Label is 2. And similarly 3 joined with 4, so 3 joined with 4, but what will be direction? 4 having positive 1 and 3 having minus 1, so the direction will be 4 to 3. So direction will be 4 to 3 and label will be 3 because the column here is 3. And similarly you can see that 4 and 5 you can fill it for 4 and 5. In column 4, the vertex 2 join with vertex 4, the vertex 2 join with 4 in which direction? 2 to 4, 2 to 4, in direction of 2 to 4. And similarly for 5, 2 join with 3, 2 join with 3, but in which direction? 2 to 3, 2 to 3, and we label it as a 5 because the column is fifth one. So that's all from my side. If you have any problem, you can contact me or concern me. Thank you so much, and Allah Hafiz.